First, welcome everyone to our third new meeting. I did render an order for the middle store, but let's still start with company update.
Things. One, I want to emphasize how important it is, AMD contract. I think that the ideal contract is the dream thing to work on training Llama 405B on ML turf. Not really. But two things about that is that is what everybody kind of wants. One thing that everybody wants is to be able to train large transformers. This is what Comma wants. This is what anybody who's trying to clone Claude Code wants. So it is very useful. And then the other thing is, I think that this contract is really important. Like, these things are really hard to get. It's not easy to get a contract with a large company to basically do work for them on something like this, right? And you can say that, oh, it's I bullied them on Twitter or whatever, but I think it's more than that, right? I think that we have a contract and we should really put forward everything to get it done. So really, everything should be focused on either that, on our other customer, comma, and improving their workflows, because we have two actual willing to pay money to use TinyGrad. One is AMD and one is comma. So everything should be focused on one of those two things. The other thing is, I was thinking about, in the context of open code being banned from Claude Code. I wonder how long it is till Anthropic actually just starts doing account bans. And then I'm like, okay, so if you have to run local models, what do you have to run? And then you realize that what you probably want to buy is a tiny box green Blackwell, and you want to run. If you with 6 of those, you could maybe barely run the ZAI model. These things are gonna become more and more important. I think more and more people are going to start to want to actually run models locally. They're not making money on it. So yeah, I wonder what the real cost of that is. The real cost of that is $2,000. Suddenly buying that tiny box starts to seem like a really good deal. So yeah, I want everything focused on either the AMD contract or the comma use cases, because these are our actual users. And yeah. So 2 in the morning for me here. So if this is my life now, where I wake up in the middle of the night, you get me.
You were caught up a little bit, at least for me, specifically for running local models.
I think that Anthropic is subsidizing the Claude plan that everybody's using now. I mean, they have to be, because otherwise, why would they care so much if you're using open code? So I think that, yeah, I think that in the next year, I think it's going to start to become really, really important. Like, I think people are really going to want to run open models as the clouds in Shitify. So we have the box to do it. We just need to have the software to do it.
Okay. Sounds good.
But yeah, the AMD contract is super, super important. The contract also potentially gives us the ability to work with AMD to buy
I cannot hear you after to buy if you are saying something.
oh, let me see what's going on. Hang on.
Also not clear if it's me or it's you.
Is that better?
I don't know. Continue talking.
I can lower input sensitivity here too. I have 2 microphones. I can try the built-in mic to my. Or I can try the AirPods. That's from the AirPods. Is that better?
Maybe continue talking.
Is this one good? Okay. Yeah, I don't know what's going on, but Yeah, the AMD contract is super important because doing well in the AMD contract gives us the ability to work with AMD to get good deals on hardware.
Right.
Realistically, it's going to be a long, long time, at least 3 years before we can tape out a chip. And in those 3 years, what do we want to buy? Do we want to buy MI350X chips? Do we want to buy RDNA 5 chips? Let's do well in the AMD contract.
Okay. I feel you are still cut off, but it's taken, and we can move on. I have a random order this week, so let's start with drivers.
Yeah, so I've been focusing on Mac USB GPU. So yeah, I'm almost completely it's completely rewritten. Like it should be a lot better user experience to install it. So it's also a shim binary now. So potentially it can be signed, but we're still waiting for notarization. And I think it can take a lot of time. I think so. I've seen a lot of messages recently on Apple's forums saying that it takes a lot of time for notarizations. And they say it's because of the holiday period, because they have a lot of requests in their queue. So I know we're still waiting for a notarization. Yeah.
So we have to do the notarization every time.
Uh, yeah.
Yeah,
I,
I
I
don't
I
know.
don't know. I mean, like for as far as I understand, like the documentation, we have to do authorization. Like we will get two different authorizations for the application and for the text. And I think text is what takes a lot of time. And if we keep it unchanged, so it will be faster next times.
Yeah, I mean, even if we're still disabling SIP, yeah, improving the install process is definitely worth it. It was super annoying to install the old one. Like that app to install it was like buggy. So is it now like does it launch it from Tinygrad?
Yeah. I mean, what exactly? Like the
Yeah.
installation? Um, no. There is separate script which you just run the script and it's install the application.
How do I
It
know
actually builds the application.
how do I know to install that script?
Yeah, I mean, no, I probably can. Yeah, okay. I mean, I can raise and like publish some instruction to do that. I think also I can install this in Tinygrad. But I don't know. That will be annoying. Like if you don't want to install this, but like the AMD is the top priority. I mean, like the backend is top priority. It will just go and just try to install and all these things. And only after that it will detect that there is no GPU.
We can't detect if there's a GPU plugged in without having it installed.
Um, and probably we can. Like I have this functionality in the app to detect and if we have the GPU in all PCI devices.
I
But
mean,
again,
the workflow that'd be really good is if Tinygrad just detects quickly that there is an eGPU plugged in, and then it sees if the thing's installed or it needs to be updated, and then it does that, and then
yeah, But actually, the problem is that no, I think it's good. Yeah, I can do that.
Cool. Just want because we're going to start selling these eGPU boxes. Just be pip install tinygrad on something, and it's like, oh, I've detected you have an eGPU. Okay, let me install the driver. But then not interfere with people's workflow who don't have an eGPU.
Yeah, this should work, I think.
Cool. Yeah, because having to know to do the extra thing, and then even if people disable SIP, do they have to have Xcode installed?
No, I think no. No.
Sweet.
I mean, currently, yeah, because currently, the script just builds from the sources if you have no SIP. But I think, yeah, I can just distribute completely unsigned binary and it will be fine.
Did you look into the Beam issues on BERT?
No. I think Prosperity you can share branch and maybe comment with me, and I'll take a look into this if you have no time.
Yes. Well, I'll look into it a little bit, and then I'll also send you a reproduction branch.
Yeah.
So I think in general, we want to lower that HCQ timeout thing.
Mm,
You ever have a kernel that takes more than a second?
you said we want to lower it.
Yeah, wait, let me switch to my phone if something's not working right. Hello?
Yeah.
Try again.
Yeah, so if we could lower the HCQ timeout from 30 seconds to 1 second or something.
I mean, yeah, the problem is Beam is that we can have kernels which take longer. And actually for our drivers, we can detect bad state faster than 30 seconds, if we have page faults.
Oh, but
That
should
works.
any kernels take longer than a second?
Of course, there are tons of kernels that can take more than a second.
Really? Like what?
Like a really badly written get item kernel that has a very big reduce. It's forever.
What's the longest kernel we've ever seen?
I think one time we even increased these 30 seconds for some beaming. I don't remember what exactly.
So now, if things crash, we're detecting it faster, right?
Yeah.
The other thing that I'm interested in looking into is so a lot of times on my computer, I'll do Beam, and the timings from Beam will be pretty different from the final timings, and I'm not sure why this is. Off by 3x.
Yeah, I see.
Yeah, I wonder if this is because of like the globals thing. Like
Uh, I remember before, even if I disable all the test size and try with the fresh thing, increase the count from your sampling, there still can be off. But it's not clear if it because it's running sequentially with other kernels, so it's got scheduled differently on the hardware or something like that.
Yeah, I mean, I'm curious to understand this and just like improve Beam on AMD in general.
I think it's also not just on AMD. I think at least for metal.
Is it possible to set the HCQ timeout dynamically? Because really, you want the upper you want to stop it anyway when you hit the upper bound of the longest kernel in the pass run.
Look,
I mean, you can.
because setting a threshold dynamically is always like janky and hard to maintain. Maybe like a realistic start is to have a proxy that's static and know if this kernel should be run long or short. Something similar to the UOP limit, that if it has stack counts of UOP, then it's likely to take longer, something like that. So it's not like we don't want to change the threshold dynamically, but we want to understand the underlying workload better. If something needs to take long, then so be it. We don't want to just, maybe that's dynamic.
Can we lower it to 5 seconds? Can we start with 5 seconds?
Yeah, we can try. I think, yeah. And yeah, I'll take a look into MD timings during Beam.
Cool. And then as kind of a stretch goal for the sprint, what does AMD have like SQTT?
Sorry?
I mean, NVIDIA like
Oh, sorry, NVIDIA, yeah.
Actually, no idea. I can, yeah, look into that.
Cool. Yeah, you know, just that we're doing like the visualizing and thinking about it. I always like to have both. Yeah, the main thing is stability of the driver and correctness of beam timings.
Okay.
Okay. Next for image D type and C type.
Yeah. So, oh, sorry. Oh, okay. Yeah. I mean, so the thing that I worked on last week was mostly this C types structure removal. I think maybe the test for this is whether or not the AMD DSL can use it. And if it's not usable, then I guess I don't know. I mean, I think it's still worthwhile. I mean, we discussed this a little bit. I think it's still worthwhile to keep it around because of the like not relying on this sort of janky C types implementation. But yeah. And then this week I'm gonna focus on getting image equals 1 to be fast. And if that works out, then image G type can go. But obviously it can't go until image equals 1 is faster than image equals 2.
Yeah, I think we should leave the new C type structure for now. I did things a bit differently in the DSL. So the way that I saw you did C type structure was that the actual types that are in the Python object are ints,
Mhm.
and that they're packed on store.
Yeah.
So I did it a bit different. I don't know. I'll look into this. I'll look into seeing if I could unify them.
Mhm.
I did it basically the types on the thing are the packed types. Like it creates like a class for each thing, which might actually be slower. So I'll look at reusing what you wrote from C type structure. But I don't think it'll be a bit
Yeah.
good.
Oh, the reason I did it like that was just because, like, when you access a field on, when you access a field on a structure, like you get an int back, or you get a bytes object back, or a float back, or whatever. So I just wanted like the MyPy stuff to be like accurate.
Yeah. No, when you access a field on the DSL stuff, you'll get like a special like VGPR type back.
I see. Yeah, I mean, we could have the fields of the structures give back like the C types object, but the problem with this is then like you have to put dot value like literally everywhere, so that's kind of annoying.
Yeah, I think it might actually just be a different use case. But no, either way, I think the C type structure changes in. I'm happy with it. Let's not mess with it anymore.
Yeah, I agree.
But yeah, image equals 1, and then anything to support the main goal of the company, which is training the AMD.
Yeah, for sure. I mean, so I think the focus is image equals 1 for this week. The other thing that we talked about previously, which is probably shouldn't be a focus, but I mentioned it, is the compiler pair removal. I don't know, like this is obviously much less important. But
No, I mean, I think the compiler pair removal is pretty important. You said you wanted to remove the device from the renderer?
yeah, so I mean, I don't know. This is, I mean, maybe I just have like a innate bias against this sort of object-oriented programming style of API. So maybe this is just, I don't know, like maybe I'm totally off base here. But it seems very awkward to me that we have like HIP renderer and AMD HIP renderer and AMD HIP CC renderer, and then like similarly we'd have like NV NVCC renderer and then CUDA NVCC renderer and then CUDA NVRTC renderer and whatever. Like this seems, I mean, I guess it's fine, but like it seems a little bit messy considering they all basically do the same thing. And the only thing you're parameterizing over is what compiler you're using. But then it's kind of like, okay, well, if your renderer accepts a compiler argument, then how is this fundamentally different than compiler pair?
Because it's one object, and it's pre-created somewhere else, right?
Mm-hmm.
So yeah, the problem with compiler pair is mostly I just don't like the way that it's like structured.
Mm-hmm.
I think that there's no distinction between rendering and compilation.
Mm-hmm.
So yeah, I mean, I don't think that there's anything wrong with having lots of those objects. That seems totally fine to me. Like
Okay.
you have an object, yeah. Like the point of that object, the point of AMD HIP CC compiler is to do a workflow that transforms UOPS into bytecode.
Yeah.
Right? And you're going to fundamentally need some object to capture that workflow.
Mm-hmm.
Right now, were you imagining it's something that's more like compositional?
Yeah, I mean, I guess basically like the thing is like there's no difference between the CUDA NVRTC renderer in this case and the NVRTC renderer, or sorry, the NVRTC renderer, because they're both doing the exact same operation. Or actually, in this case, no, one of them's emitting PTX, but in general, like you could have, there's examples of this where they're doing the exact same operation, and the only thing different is the renderer.device.
Well, that's okay. So that's a different issue. That's a different issue. And if you can fix that, I think that's a good idea, right? But what you should think of as the renderer. The renderer is just a transformation from UOPS to binary.
Yeah, no, that makes
And
sense. Yeah.
for every type of transformation, if you're doing one with HIP and HIP and then calling HIP-CC, HIP and then you're using co-manager, right? Those should be separate renderer objects.
Yeah, no, that makes sense to me. Yeah, the best example for why this is like a sort of maybe not great is where you're like the only thing different is the device, and the actual renderer is just doing the exact same operation.
Yeah, if you could refactor to remove that, that would be great. Like, yeah, I agree that that the CUDA, whether it's being run by the CUDA backend or the NV backend, the renderer should have no knowledge of that.
Okay. Cool. Yeah.
Cool. But you know, I think that actually is. I think that actually is pretty important. I think that paying off. Okay, so in general, coming back to the stuff about why we never do fast paths, the most important thing that we do at this company is that we keep the tinygrad code simple and maintainable and bug free. Right? Speed doesn't matter. Features don't matter. You know, nothing else. You know, all of speed, features, complexity. These things increase technical debt. And I think that in software in general, there is way too much technical debt. Right? This doesn't exist in hardware. When someone's building a chair, they're not just gonna, you know, import a 200 meg chair updater library and just be like, well, it's in there and it works. But yeah, so I think that things like the compiler parity factor are quite important. And we should do that. I'm thinking about how to do like now that we have that, to get everything to work with the new program abstraction.
Okay.
So then the lowering actually happens in the thing. So
yeah, that makes sense.
Image equals 1 and compiler pair seem like good goals for the sprint.
All right.
Okay. Next is George, your assembly stuff.
Yeah, so I made pretty good progress. You know, I should have started with the XML stuff and not the PDF stuff. The biggest thing that the XML has that the PDFs don't. So AMD publishes these XML files that explain all the instructions, and the biggest things the XML has is it explains the type of every operand. That turned out to be annoying in everything. But I switched to the XML, so now like everything is type checked. So when you're doing like a global load, the global load has to have the right number of registers for each argument. It has to be a VGPR if it's a VGPR, an SGPR if it's an SGPR. The offsets and stuff always were checked correctly, but yeah, now it checks the, like, if it has to be a pair of registers, it's a pair of registers, even though that's not actually encoded anywhere in the instruction type. Because the instruction just specifies the base register, and you have to just know that it's 2. But I extracted all that from the XML. So yeah, all that works. I cut the stuff that was doing the LLVM to our bytecode, so it can't function as an assembler. But all the disassembler stuff works. Disassembler and round trip work for CDNA, RDNA3, and RDNA4. Quaslin, I saw you have that one. MFMA instruction that doesn't work. We should fix that. If the hardware supports it, we should be able to express it. Yeah, and then what I've been working on for the last couple days is the emulator. I have an emulator now that compiles everything to actual tinygrad programs. I think we can extend it to just do basic blocks. So we can just take a basic block of AMD instructions and transform that into a program that executes in the normal tinygrad workflow. And yeah, so my goal for this sprint is to extend that emulator to CDNA, RDNA3, RDNA4, and then get all this stuff. It should be about 2,000 lines copied into the main tinygrad repo. DSL, SQTT, emulator. Yeah, kind of like a nice development environment and a foundation that we can start to build on as we handwrite the kernels for the MLPerf contract. Yeah, so I think it is going to take the rest of the sprint also to make the code really clean. You know, a lot of it is written with Claude, but I'm aggressively going through it line by line. I think the code quality, by the time this gets merged into tinygrad master, will be on par with everything else that's in there. Well, I won't merge it if it's not.
Sounds good. Next is my stuff. So I mostly work on one is understand JIT issues, is assign. I think 2 of the biggest thing we know there are bugs or issues. So for JIT, it's mostly asserting the easy cases now. There is one that I'm working on. Basically, we want to assert when you access underscore buffers, like if you call like toList or item and you use that in your tensor function. So think about like mask field or anything that is data dependent. We want to assert that in JIT. So the check itself is easy, but then I run into another issue in Onyx that previously in Onyx as a hack or speed up for OpenPilot model, it has a special path for gather. So if gather's input indices is a const, they always assume it's a const if it's small size, then use the item basically from that to now treat it as a const and do special path. And that was causing issue because that obviously caused underlying buffer during JIT. So I fixed that to detect from the Onyx model itself. So first, at least make sure it only triggers when it's actually a const. Now I need to find a way to. I have list down in the Onyx cache stuff that's currently correct and pass the test, but I'm not too happy about that. So I want to also refactor that part. In Onyx, we do some special caching from the tensor to like Python objects, and we want to make sure there's only one path for this. So after that, I think JIT assert is in the pretty good places. I also went through all the open issues with JIT and try to either assert stuff or just fix it. The goal here is I hope once we understand the issue and have no like a known issue, then we can think about how do we want to refactor this, how to make it as simple as possible, reusing the schedule cache and stuff like that. So that's JIT. Assign is more interesting because assign started with a lot of to-dos in Tinygrad examples saying you must add a contiguous here or you must add a realize here, otherwise it's wrong. Then turns out assign is just really broken and it doesn't handle many of the cases. So my current state is I wrote a very big, I guess Claude wrote most of it. I just asked it to write it. A lot of cases for assign and how it was wrong previously. Now I have a giant PR that has 100 lines of handling the write after read and read after write and stuff like that to make sure it runs correctly. So my idea here is similar to JIT. Once I make sure all the cases I can think of that passes, then I would think about the correct way to merge this. Because some of this needs to be in the tensor level, because the information you lose while you try to schedule it, or very hard to recover while you try to lower it to schedule. But after this, we can remove all the to-do realize bug, to-do contiguous bug, and another related thing is to make the disk tensor lazy bug. So I think that's a pretty nice place to be. So that's assign.
It would be great to remove those disk tensor hacks, those like if disk tensor things.
Yeah, the fundamental issue is, so I started this by working with Cloud to fix that. Then you realize if you just fix it in the disk level, then it's tons of crap. And it's just because it's trying to work around the bugs in assign and scheduler and renderify around area. So I'm on this finding to do and try to root cause that, see the solution, and realize it's another bug in another part. So I think assign is pretty fundamental, so it's good to understand what's going on there.
When we do we have get item without realize? Does get item realize?
Nope.
How about set item?
Set item With my fix, no.
Oh, that's great. Yeah, if set item doesn't realize now, that's a big win.
Yeah, you shouldn't realize. Or I guess the first thing Cloud would do is find a place and add realize for you, but
No,
yeah.
but
No, the idea is how do you capture this dependency in your app, and which might like point to the other objects that you have like no information if it's being changed later. We talk about this. I think my principle here is the ground truth is the eager execution. So the outputs, we always match what would be the eager output if you realize every line. Then we want to embed this structure in the UARP lazy graph.
yeah, that seems right.
Yeah.
You look at the way that like RL people use TinyGrad. They do tons of like set item assign stuff.
Yeah. Also, I fixed another thing that in Carol's issue, if you like slice your window by a shift because there's a buffer reuse, then there's a bug, something like that.
Mm.
So I think all these are pretty related. Just some of the use case that we never fix. So it's nice to fix those. One last thing I want to get fixed is, so I look into the my reports, and two biggest issue that we have in precision, or I guess it's called any, like they can simply cannot refer. One of it is the mixing. So you try to add return self to mixing, you got tons of errors. And a lot of those, it's because of invalid. And this is a slightly annoying because invalid is only a concept that should exist in UARP. You should not use invalid in tensor on the ALUs. But the mixing currently support both. Don't have a good solution there. Otherwise,
You mean like
so if it now in invalid, now in mixing, those ALU functions should return self type. If you
yeah, they support tensor and UARP.
Yeah, but it also supports const type as like Python objects, because you can do like it applies UFix for you, so you should it works
Oh,
in,
and you can put invalid in there. I see.
yeah. So the two practical solution is either, so adding invalid type to const is bad because tensor use that, and a lot of places that only accept Python use that. But if you don't accept that, then if you try to run typed with a D equals to 1, then it complains about invalid, and everywhere it doesn't accept invalid. Don't have a good solution now, but I will think about this more. Because I think this is like half of our MyPy any error, and also the main reason why type equals to 1 is wrong.
Yeah, I thought I fixed this. I thought that I have some stuff working with type equals 1. Like I have like basic stuff working. Has that
Yeah.
regressed?
So I think previously we only test the import statement is correct, and not
No,
really
but
running anything.
I've run stuff with it. I've run like test tiny with it.
Oh, then maybe it regress with the new invalid. I don't know how recent this is. Oh, so I think it's maybe after we move more stuff to mixing that it regress.
I see.
Because previously it's like separate as two subset of functions, right? And it probably can infer that part of it accept invalid and the ones in tensor doesn't.
Yeah, this must be some kind of regression because this used to work. I see the invalid thing now.
Yeah. So I mean, working with Cloud, it seems to, it will use any metadata type information it can use to try to guess what functions to use. So I think fixing this is useful in general. And also just makes you realize maybe there's some like design errors or things like that.
No, I agree. I mean, that's why we have typed equals 1. It should eventually all pass with that. Yeah, I should put this in CI.
We have the one that
type.
has import, and yes, once we fix this, I think run with test tiny and if that pass seems pretty good.
Cool.
Yep. Good stuff. Next, llama training.
So last week we have BERT training with flash attention now. It's pretty good. It is slower than normal attention, but then it's also not really comparable because none of the 2 runs were beamed. We'll look into that. And then the goal of this sprint is mainly just to get Llama 8 training. And that should be fairly doable. And then I can start landing performance improvements. Mainly, the backwards kernels are currently, there's 3 kernels, and then really should only be 1 kernel.
So yeah, I'm not worried about performance. I'm worried that 2 people had on their sprint last week that we were going to have Llama 8B training, and we don't have Llama 8B training.
Yeah.
Yeah, so we need, regardless of performance, we need to get an MLPerf qualifying Llama 8B training as soon as possible.
Okay. I'll focus on that this week then.
Cool. Yeah. And then, so yeah, BERT works with flash attention. Did you run it with null and see how much RAM it uses?
For Llama 8B,
Yeah, with the 8192 context.
I haven't yet.
But yeah, no, this is, I mean, we have to get, if by the end of this sprint, we don't have a Llama 8B qualifying training, I'm very worried.
Yeah.
But yeah, is there anything that anyone can help with?
I think the most important thing is making sure flash attention works and works correctly. Because it's one of the important things that we don't yet know is how many tricks we really need to we still need to run 4 or 5B. And we use BERT and we use 8B as a proxy to verify the flash attention works. But we all know that we need a lot more tricks for 4 or 5B to work.
Why do you think? I think if we have 8B training, I think it's a pretty straightforward scale up, right?
No. You need to
Why?
split the model and you need to do gradient grid checkpointing.
Oh yeah, but
And
that
you might
stuff.
need float 8.
Well, if we need float 8, that's a bigger problem. But I'm not worried about splitting models and gradient checkpointing.
Okay.
I'm definitely not worried about gradient checkpointing. I don't really understand splitting models.
I think maybe just in general, it's just we don't quite yet understand the extra memories we need for computation now. So
Well, we can also start adding these tricks to Llama 8B. Like we have to get a qualifying Llama 8B run as soon as possible. How long do we expect Llama 8B to take to train?
they have 2 hours, right? So magnitude of that.
Yeah, so something we can comfortably iterate on and have a Llama 8B training every single day.
That makes sense.
Yeah, so if we have a Llama 8B training like every day, we can start adding these tricks. We can definitely do gradient accumulation and model splitting on Llama 8B. And then not worry about scaling up to 4 or 5B and not worry about performance. Just make sure that we have this thing training, it's MLPerf qualifying, and we start to add the tricks to it.
Yep, sounds good. I think once we validate and know flash attention works with the AK context, it's a pretty good progress. Then maybe just copy some of the hyperparameters and just train it. With Bing, preferably.
Yeah, we should get Beam working. But
Okay. Anything else
Um,
for training?
No, I think that's mostly everything.
Okay. Oh, next is Viz and Jam and yes.
So we have the SQTT timeline now. And I think this week I'm gonna add support to our reverse engineered unpacker for CDNA. Currently, it only works on RDNA3. I looked into a little bit for RDNA4. The packet structure is different. The timestamps are different. It'll be fun to see what we can get out of it.
yeah, Claude should be pretty good at that. So all that
spent an hour on it. Spent an hour on it. It doesn't work.
Yeah, I mean, you have to get it. So the way that I got the stuff for RDNA 3 was I disassembled ROCm trace decoder in Ghidra, and then I pasted that C code into ChatGPT. Then I also did a bunch of GDB stuff to dump the tables. I dumped all the stuff out of Rockcraft Trace Decoder. If you don't get this like within like a day, don't spend a ton of time on it because I can do it very quickly. I think it's more important that that you spend time on the visualization side of things, making sure that we can tie every packet back to an instruction. And then also things like making sure the barriers, like right now, barriers just hard coded to have length 100 or whatever. Making sure the barriers actually go to the end of the barriers. And then there's also the mystery of the wave ready packet. If you could figure out how to show those in a good way. But yeah, no, we definitely need to add CDNA, but don't spend a ton of time on it. If you find yourself spending more than a day on it, I think I can do it really quickly.
Yeah, I'll continue working on this stuff.
Yeah, no, I'm very happy with the the SQTT trace view. I think it's a lot better than stall on instructions, which doesn't make any sense.
Does not make any sense. Yeah, this one's like I can see every single cycle.
Did you see my warp specialized stuff?
Oh yeah, the warps are doing different colors. You see the
Yeah,
you have different colors. So you see it.
yeah, you can I think that's well, yeah, we should get this ordered for CDNA because we can look. I think that the one from is AMD's one warp specialized. I think the one from the Mojo is warp specialized. Fast Jam.
Oh, the fast jam. I don't know honestly. I haven't read that.
But yeah, no, don't try a little with CDNA, but if it's like totally different, yeah, I can do it real fast. But yeah, I want to be able to click on any instruction. Either like we need to tie the exec to the NQ.
Do you think it's actually possible to do it, like accurately?
Of course, it's all in order. At least RDNA 3 is all in order. So the order in which the NQ packets appear in the SQTT stream is the order in which the exec packets appear. Have you seen anything to think that's not true?
No, I think that's true. I mean, I hope,
Mm.
because otherwise it would just be impossible. Like it would be like modeling a CPU. No, you can't do that. But maybe GPUs or
Yeah.
something.
Well, yeah, I looked into trying to model cycle accurate stuff. I don't think that's going to happen. There's a lot of noise, but I don't think that matters. But I think, yeah, I think it's all in order, so you can definitely tie them back together. It'll be great to be able to click, and then yeah, see what's going on, and then also eventually we want this environment to be able to run the emulator. And in the emulator, we can see at any point what all the actual values of the registers were.
I see you want an emulator, but
Well, I mean, it'll make a request for like what were the registers at this timestamp. But yeah, no, much less important. More important is to get these things reliably tied back to PC, and then yeah, start using this to improve the speed of things. Yeah, spend a day on the CDNA thing, see if you can get it. But yeah, I think the right way to do it. Did you see my tests that compare it to Rockprop Trace Decoder?
I did. Yeah, the SKTD examples.
Yeah, if you just what I would do, here's what I would do. Make a generator for those examples. I just generated those examples by hand, but make a script that auto regenerates the examples and add the same set of examples for CDNA, RDNA3, and RDNA4. And then yeah, tell Claude to get them to pass for CDNA3 and RDNA4. See if we can do it.
Yeah, I did this for RDNA4. I generated exactly the same things. It spends it spends like 2 hours on it, and then it's hopeless.
I see.
So you'll see it.
But
I
yeah,
mean, like
either
that has
way,
been my experience with it. Like it writes a lot of code and
yeah, no,
creates
it can't.
workflows to
My
read code.
experience with it is it can run for about 2 minutes autonomously without me having to say, don't do that.
Supervision.
Yeah, like I'm pretty aggressively in the loop. But yeah, what would help me to work on this is if you write something to generate all those pickle examples and generate them for all three. And then add to that test and say, should work for CDNA, should work for RDNA4, but expected failure.
Yeah.
Cool.
Do you have anything related to running the fast gen in training?
No, the current gem only works for square matrices, and BERT needs like any MNK. So
Where'd you get a gem from that only works for square matrices?
Torch
How does Torch do not square matrices?
uses other kernels.
See. It doesn't
I
seem
have a
like a
script.
lot to ask. It doesn't seem like a lot to ask for to have a gem that supports rectangles.
Yes. I have a script for it. I have I can get the full dump of Torch. It will take me like an hour to get this.
Cool. Yeah, I think that's another good goal for the sprint. Because yeah, fast gems is just free speed up for training. The other thing too, I saw you had a PR that's half done with the removing the ML having ML just directly generate.
Yeah, having the elf directly generated. It's fully done. I mean, like I merged it, and then I merged master, and it broke.
Yeah, just
Today I fixed it.
I can tell that some of that stuff's AI written. Just clean it up a little bit more.
The elf? No, that elf is handwritten.
Oh, that's handwritten.
That is interesting. Yeah.
All
Like a
right, all
little-
right.
Yeah.
I think it could be cleaned up a bit more. It was just my. Oh, I thought that's why it wasn't merged.
Feel free to comment on it. Honestly, like
No, I just thought that that's why it wasn't merged. I thought it was waiting for cleanups to Alf. Oh my goodness. Oh wait, never mind. Oh, this has changed. Yeah, this looks pretty good. Did you have an older one beforehand?
I might have.
Yeah, no, this looks pretty good. This is pretty minimal.
Yeah.
What?
I also have some fixes for cDNA DSL. It's in the same branch as my failing test. It's by Claude, but I reviewed it a lot. I think it's correct. Like it's some sort of like bit field issue with FP4 that you don't have you don't have 7 SGPRs, you have 4 SGPRs or whatever. But it's smaller.
Oh, one of those is wrong somehow? I mean, I just pulled all that from the XML files. There are some bugs in those files.
Does the XML file describe based on a field, like based on a modifier, your register range changes?
Oh no, it just has the biggest one.
Yeah, that's how FP4 works. Like based on the modifier, your
Got it.
register range changes. That's all I have.
Cool. I'm wondering what I read before. Yeah, this looks good. The alpaca looks good.
I get much.
Great.
Okay. Do we have anything on bounties? Don't think so. Don't remember.
It's so frustrating now with all the AI crap. Like every time there's a bounty that's like, I don't know. I mean, I think that there's like people out there who just copy and paste the bounties into Claude and say go, and then like they did the easy part. The hard part is telling if it's good or not, which it probably isn't.
I think on average, I get like 5% of the code, actual code, and just throw all other 95%.
I know.
I also
Overall,
heard Codex is good. I'm going to try that this week. There's a $20 tier first.
my friend did a study on whether AI makes her company more productive or not, and the end result was that there's no productivity change. I now see, having spent the last month using Claude aggressively, I see how it could potentially just make me less productive. The problem is you don't realize what you shouldn't be doing. Like you just go down a rabbit hole that you shouldn't go down, and you don't really realize that because you're not doing it. It's not your effort being expended. It's like the virtue of laziness.
Okay. Anyway, I think that's it for this meeting. Thank you, everyone. See you next week. Bye bye.
Thanks. Bye.